Let's try factoring. Number 9, we have a trinomial, and we really should factor out the GCF. So let's factor out 100 and see what happens. If you try to factor this without factoring out 100, you'll have a big headache. But if you pull out 100, the question is quite easy. 2x squared plus 5x minus 12. When you feed the dog, feed the cat, and feed the bird, you'll realize that this is equivalent. So all we have to do now is to focus on factoring this trinomial here. So for the sake of relaxation, let's try one more time this rainbow method. Let's change the color here. We're going to work on a sub problem up here. This is, so when you do the rainbow method, we have x squared plus 5x minus 2 times negative 12 is negative 24. So we're going to factor this. What times what is 24, yet adds to be 5. Let's try 3 and 8. Positive wins, so we'll put the plus sign here and the minus sign here. You can see that when you multiply, you get this constant, yet when you add, you get the coefficient of x. So we did it correctly. We just have to follow up with the story of you being the underdog. So this is already simplified, so you can be promoted. So the answer is 2x minus 3. 8 divided by 2 simplified is 4. So we have a factored form. So we have accomplished factoring this trinomial here. Do not forget about the coefficient. So now this result is, by the way, this is 2x minus 3. I forgot to finish that off there. 2x minus 3, x plus 4 is fully factored. Now let's try question number 10. We have the a value, which is square rootable, and we have the second part, which is also square rootable. If, for example, this is focusing on question number 10, let a equals the square root of this expression is 3x. And the second part, let b equals the square root of this, which is 5y cubed. If you think about the meaning of a squared minus b squared, that's exactly what we have here. And we know that we can factor this as difference of squares. It's a plus b, a minus b. So let's do it. If you recognize that these are square rootable and you have a minus sign here, you can factor directly using difference of squares. So this is going to be a, which is 3x. We have a 3x here. We have a plus sign and a minus sign, and we just have to take the square root of 25y6, which is your b value, which is 5y cubed, 5y cubed. And if you FOIL this out carefully, you'll realize that we do indeed have an equivalent expression. This is very similar to the next question. So let's always, before we begin, we really need to think about what we're doing here. This is difference of squares. This is square rootable. So let's just attack it right away. What is the square root of the first term? The square root of 4 is 2. The square root of 79 is, the square root of 49 is 7. And the square root of these is going to be a2b. Let's just give a little bit more room here. It's going to be a plus and a minus sign. And let's copy this again over here. This is 2/7 a squared b. And we're simply going to take the square root of this term here, which is 1 over 10. The square root of the top over the square root of the bottom. And if you expand it out, you'll realize we have the same expression. All right. For question number 12, notice how we have two factors. We have two terms. And what's common, the greatest common factor, what's common to both parts is x minus 1. So let's focus on factoring this GCF out. So x minus 1 is the part that's the same. And let's use big fat square brackets to reconstruct the original question. So what we have is x minus 1 multiplied by x squared. So let's put the x squared here. It's going to be x minus 1 multiplied by x squared. That's our dog. And then we're going to have a cat being the 4. So when you feed the dog and you feed the cat, it's going to be x minus 1 times 4. X minus 1 times 4 is the same thing as 4 times x minus 1. We've reconstructed this original expression in a factored form. And when you look carefully here, do not factor any further because we have a plus sign rather than a minus sign. This cannot be factored. So we're done. Okay, it's your turn.